Titration. Today we are going to discussing types of the plot. Which type of the plot are there in conductometry titration? Conductance is due to ions. So it is due to free flow of ions. Sometimes conductance may increases, sometimes it may decreases. So that will depending on mobility of ions. H plus is highly conducting ions and OH minus is or Na plus is somewhat less conducting ion. So see what happens if you having strong acid versus strong base. This type of the titration you have already completed. Suppose if you having see a strong acid versus strong base, this is suppose your burette, which is having this burette contain here it's a suppose solution of strong base NaOH. NaOH is there in the burette. What happens? Strong base is there in the burette. So you can have a suppose this is your burette which contain NaOH. And in the beaker you have taken HCl, strong acid. Now see H plus conductivity of H plus is higher than that of Na plus, or you can say OH minus. So during titration, what will happen if you add NaOH from burette? So Na plus ions of NaOH will take the position of H plus. So H plus of acid is replaced by Na plus. So you are getting NaCl plus H2O. This is the reaction. So see, highly conducting H plus ion is replaced by low conducting Na plus. For example, see conductivity of H plus is at under standard condition it is 249 ohm inverse, and for Na plus is 150 around 150 approximate ohm inverse. Okay, so what happens if you add Na plus and remove H plus? So H plus is removed, so 249 value is removed, and you are just adding 150. So initially conductance is decreases. This is due to replacement of HCl. But say after endpoint, after neutralization of HCl, you are further adding NaOH, then what happens? Initially see it is decreases because H plus is replaced by Na plus, but all the H plus is replaced. Further you are adding NaOH, then it start to increase from here. See, this is increases due to NaOH, Na plus and OH minus. Burette માંથી NaOH continue add કરો છો તમે. That means you are adding continue 150 value and replacing 249. So initially it was decreases, but all the H plus is removed. એટલે 249 વેલ્યુ પછી બંધ થઈ જશે ડિક્રીઝ થતી, કારણ કે બધા H plus replace થઈ ગયા છે, and you are adding NaOH continuously. So then because of Na plus and OH minus ion, conductance is increases. So this is about strong acid versus strong base titration. HCl versus NaOH, this type of plot is there. You may ask in the exam, this is your end point. Okay, in competitive exams, different type of plot is given. You have to identify appropriate one. But what happens instead of you are taking C strong acid, if you are taking C weak acid in the burette and doing titration again with weak base, sorry, you are taking weak base and do its titration with HCl. Here this is a weak base NH4OH, or you can say liquid ammonia. So in this case, initially of course H plus is replaced by NH4 plus, so it is decreases. But after end point, you are adding further NH4OH, so it's a weak electrolyte. So NH4 plus and OH minus ion is not available fully, and therefore the conductance remains constant. It is not increases much more. So this is the B is the plot of strong acid versus weak base. This is a strong acid versus weak base with weak base. And this is a strong acid versus strong acid HCl versus strong base. Here it's HCl versus weak base. So see, this is the nature of the plot. If you're having say plot of conductance versus volume for strong acid versus strong base, then this is the nature. If you're having plot of weak acid versus strong base, then this is, sorry, weak base versus strong acid, then this is the nature. Here it's NH4OH. So this is the signature. I have written this is the combined plot of both. What happens if you're having weak acid versus strong base? See, weak acid, this is a strong acid HCl versus NaOH. And this is a weak acid, see, especially weak acid, acetic acid versus strong base. Strong base is, for example, you can take NaOH. Weak acid, you can take acetic acid. So this is the plot. Initially, this is remains constant due to neutralization of weak acid. After that, conductance is increases due to NaOH. Here, this is a plot of strong acid, that is HCl versus strong base, that is NaOH. And this is a mixture of acid. This plot is ultimately nothing but mixture of HCl and acetic acid versus NaOH. Again, here see, this is the first one, that is mixture of acetic acid and HCl versus NaOH, strong base. So see, this is the nature of plot. Here it says Cl is neutralized. Because HCl is a strong electrolyte, so HCl is neutralized first. After complete neutralization of HCl, then if you further go for adding more NaOH, then acetic acid is from here, it is start to neutralize. If acetic acid is neutralized, then it remains, then conductance is increases due to NaOH. So this is the nature. HCl is neutralized, then it is increases slowly, and then it is increases sudden due to NaOH. This is acetic acid. This is HCl. This is your first endpoint, that is called V1. This is your second endpoint, that is V2. So for acetic acid, for HCl endpoint is, for HCl endpoint become, endpoint is volume required for neutralization is V1, but for acetic acid, It is V2 minus V1. It is a V2 minus V1 ml. So this much volume is required for neutralization. And if you having see mixture of acid versus weak base, this is a strong base. But if you having a weak base, then this is the nature. This is for weak base. NH4OH. And this will be the nature of the plot. Acetic acid, NH4OH, and this is HCl. Acetic acid neutralized થાય ત્યાં સુધી slight increase થાય, and then it remains constant. It becomes steady. So this is the plot of different type of titration. What happens in precipitation titration? So see, this is a precipitation. This is first one is nothing but it is a titration of AgNO3 versus NaCl. When NaCl is react with AgNO3, so you are getting precipitates of AgCl and NaNO3. So this is due to precipitation. Ag plus and Cl minus ions, they get separated, and due to precipitation, see, this is the plot. If you add more and more AgNO3, so more and more AgCl is formed, and NO3 minus ions gets removed. So see, in this case, what happens? Chloride ion is replaced by Cl is replaced by NO3. So Cl is replaced by NO3, so you are getting white precipitates of AgCl. And therefore, due to this precipitation, due to formation of different solid precipitates, conductance is only produced due to free ions. If you are having free ions, then you can have a having certain conductivity value. For mobility is depending on free ions. If ions is free, then it become mobile. It can easily or it can be movable. So in this case, NaCl when react with AgNO3, so it will give you NaCl plus AgNO3. So during this precipitation, this is a reaction, precipitation reaction. Mobility of Cl minus ion and mobility of NO3 minus ion. Mobility, the movability of, or you can say conductance, mobility of NO3 minus is 71.5. Cl minus is 76.3, almost equal. And therefore, there is no much increasing in the conductance. કારણ કે fast moving ions replace થતા હોય slow moving થી તો conductance decrease થાય. And if slow moving replace થતા હોય fast moving થી તો conductance increase થાય. But here it is same mobility. And therefore, there is no much. Of course, conductivity or mobility of Cl is higher than that of NO3. So Cl ions આમાં જે free છે એ replace થાય છે. અને AgCl તો solid બની જશે precipitation, એટલે હવે Cl ion available નહીં હોય. NO3 માઇનસ અવેલેબલ હશે. એટલે શરૂઆતમાં આ રીતે આમ સ્લાઇટલી ડિક્રીઝ બતાવવું હોય તો બતાવી શકે શરૂઆતમાં સ્લાઇટ ડિક્રીઝ, અધરવાઇઝ ઇટ ઇઝ કોન્સ્ટન્ટ. Why it is slight decrease? Because 71 value is added and 76 is replaced. But after precipitation, if you are adding more and more AgNO3, then it is increases due to, here see, this is due to Cl minus, this is due to Cl minus and NO3 minus ions. After that, then you are adding more and more AgNO3, then due to Ag plus ion and NO3 minus, conductivity is increases. So this is called precipitation plot of formation of AgCl. Here it's a BaCl2. If you having BaCl2, when it is added to Na2SO4, so it gives BaSO4 white precipitates plus 2NaCl. Here what happens? Which ion is replaced by which one? So here it's a 3Ba plus 2 ion and 2Cl minus. Of course, here it's a 2Na plus and Cl minus ion. But Na plus ions gets, see, Na plus ions is replaced, or Ba plus 2 is replaced by Na plus. Ba plus 2 is replaced by Na plus. 1 Ba plus 2 consume 2 Na plus. So ultimately, highly conducting ions, highly mobility ions. Mobility of Ba plus 2 is higher than that of Na plus. Here mobility of Ba plus 2 is higher than that of Na plus. So therefore, highly conducting Ba plus 2 ion is replaced by low conducting Na plus, and therefore initially conductance is decreases. Reason to decreasing in conductance initially is replacement. See, Ba plus 2 is the heaviest ion among all, and it has the highest conductivity, or highest you can say mobility. So highly mobility ions Ba plus 2 is replaced by low mobility ion, that is called Na plus. Lithium plus ને સૌથી ઓછી હોય. Okay, lithium plus. So mobility, highly mobile ions is replaced by low mobility Na plus, and therefore it is decreases. But after formation of BaSO4, then due to Na plus and Cl minus, then you are further adding NaCl, then due to Na plus and Cl minus, conductance is increases. In this way. In short, see here, Ba plus 2 is a highly mobile. Okay, and Na plus is less mobile, and therefore highly mobile ion is replaced by low mobility ions, and therefore it is decreases. We have already checked it for Cl ions. We have checked it for Na plus. Okay, so here it's a Ba plus 2. It is, its mobility is highest as compared to that of Na plus. If you want a value, then Ba plus 2 having C mobility value or conductance value is equal called it's a 63.6, and Na plus is 50.1. This is literature value. So what happens? 63 value is replaced by 50, and therefore it is initially decreases. After that, then it start to increases. Okay, this is the mobility value for cation. H plus having C approximate 349, not 249. It's highly mobile ions. So this is all kind of nature of plot. These are possible in, you can say, conductometric titration. During conductometric titration, these all are the possible plot, which are very, very important. Strong acid versus strong base, weak acid versus strong base, mixture of acid versus, you can say, strong base, and the last one is strong acid versus weak base. Weak acid versus weak base. This is very, very important. So this is very different type of conductometric titration. Now next we go for one of the very important law that is called Debye law. What exactly happens in Debye law? What is Debye-Onsager equation? So see, this all are the very, very important things, or you can say important parameters. So Debye-Onsager equation is very, very important. Last topic of this chapter. Debye-Huckel Onsager equation. So see, it is nothing but, you can say, lambda C is equal to limiting molar conductivity C minus B under root C. We can say under root small c. So see, this is basic equation. So here B is a constant. This is a Debye-Huckel equation. B is a constant. C is equal to concentration. So here, see, you know very well. This equation is similar to y is equal to mx plus c. Lambda 0 is limiting molar conductivity at infinite dilution. Better way you can say it is infinite dilution, limiting molar conductivity. And this is a molar conductivity. This is at infinite dilution. You can also write down in this way. And this is a molar conductivity. So here you can you can draw the plot of molar conductivity versus under root C, then it become negative slope. Slope equal to B constant negative slope, and intercept is equal to limiting molar conductivity. You can see modify this equation by taking log on both the side. So here B is the constant. B is written here, it is constant. So how to write down this equation? B log under root C. So see, using this equation, you can have a see plot of log, particularly log, or you can have a say under root C is nothing but C raised to 1 by 2. So 1 by 2 comes on front side. So it becomes simply log C. So if you draw the plot of log versus log molar conductivity versus log C, this you can also write down in this way. C raised to 1 by 2 under root 2 means it is written here. So this is one of the very important equation, and this equation is very useful to calculate limiting molar conductivity. But one more equation is there, that is called Debye-Huckel limiting and Davis law. What is that law? That is very important. Apart from this, then another important law is Debye-Huckel. આ નેટ એક્ઝામમાં ઇક્વેશન પૂછાઈ ગયું છે for ionic strength, especially Debye-Huckel limiting law. Debye-Huckel limiting and Davis law. This is for ionic strength. What is this? What is Debye-Huckel limiting law? Limiting law for ionic strength is log gamma I activity coefficient अथवा gamma plus or minus a લખાય is equal to minus a Debye-Huckel constant Zi square ચાર્જ હોય એનો સ્ક્વેર કરવાનો under root I, where gamma I is activity coefficient. A is Debye-Huckel constant. Theta is charge and I is ionic strength. What is the Davis law? No need to go to Davis law. Okay, chalo. આ law છે enough છે. Otherwise, Davis law is also represent minus a Zi square into under root I upon 1 plus under root I minus Bi. But એમાં આપણે નથી જતા. Simply it's you can go for Debye-Huckel law. So how to calculate ionic strength? ઘણી વખત I થી represent કરાય. Sometimes it may be represented by, you can say it is represented by Ci, sorry, mu. म्यू थी पण रिप्रेजेंट करी शकाय, or it is represented by I, symbol I. So I is equal to ionic strength. I is equal to I, or you can say mu, is equal to 1 half Ci Zi square. સમેશન કરવાનું છે, સિગ્મા 1 હાફ સિગ્મા Ci Zi સ્ક્વેર, આ રીતે. એટલે ચાર્જ અને કોન્સન્ટ્રેશનનું મલ્ટીપ્લાય, ચાર્જનો સ્ક્વેર કરી કોન્સન્ટ્રેશન સાથે મલ્ટીપ્લાય કરી અને બંનેનું સમેશન કરવાનું છે. સો ધેટ ઇઝ કોલ્ડ Ci Zi સ્ક્વેર. Sometimes see it is written Zi square. This law is also written as log gamma plus or minus, that is activity coefficient. A ની વેલ્યુ આપી દીધી હોય, the activity coefficient plus or minus is equal to minus A is equal to 1.173 અને Zi square છે ત્યાં Z plus અને Z minus મોડમાં કેટાઇન એનાઇન નો ચાર્જ એનો મલ્ટીપ્લિકેશન ઇન્ટુ અંડર રૂટ I. આમ પણ તમે આ લોને લખી શકો. Both are the same. Okay, you can write down this is in this way also. ડેબે હકલ છે લો એ તમે આ પ્રમાણે પણ લખી શકો. તો સી એક્ઝામ ની અંદર કરેક્ટ ડેબે હકલ ઇક્વેશન કયું છે કે આવું પૂછતા હોય છે. તો સમટાઈમ્સ એની અંદર આપણે પણ એક વસ્તુ એ પણ અંદર ઇન્ક્લુડ કરી દઈએ કે આયોનિક સ્ટ્રેન્થ કેવી રીતે કેલ્ક્યુલેટ કરી શકાય. ફોર્મ્યુલા તો લખેલી જ છે, but how it is calculated, so that is also very very important. For example, તમારે 0.1 molar PaCl2 ની ionic strength find out કરવી છે. So how to calculate it? This is very very important. નોટ્સ ઇક્વેશન લખીએ છીએ એમાં પણ આપણે અલ્ટિમેટલી એક્ટિવિટી જ મેન્શન કરતા હોય, અને આ ઇક્વેશન જે છે એ ગેમા પ્લસ ઓર માઇનસનું છે, એમાં જે ઇન્ક્લુડ વેલ્યુ કરીને લખેલ છે. બટ આ લોગવાળું ઇક્વેશન જો તમારે લખવું હોય તો આ રીતે લખવાનું, ડેબી હકલ લિમિટિંગ લો. કરેક્ટ ઇક્વેશન કયું છે નેટની અંદર પૂછાય છે. સો લોગ ગેમા પ્લસ ઓર માઇનસ વાળું ઇક્વેશન લખવું હોય તો આ પ્રમાણે લખવાનું, log gamma plus or minus is equal to minus a ની વેલ્યુ 0.509 ઘણી વખત એ આપશે અથવા 0.509 પણ આપશે આ રીતે. મોડ z પ્લસ z માઇનસ અંડર રૂટ I. આ પણ ડેબી હકલ ઇક્વેશન જ કહેવાય. A is a activity. એક્ટિવિટી કેલ્ક્યુલેટ કરવી અથવા ગેમા લોગ જે ગેમા છે that is nothing but activity, અને I is the ionic strength. For example, તમારી પાસે KBr નું સોલ્યુશન છે 0.05. તો એની માટે કેવી રીતે એક્ટિવિટી ફાઇન્ડ આઉટ કરી શકાય આપણે ગણીએ. સપોઝ I am having KBr solution. This is the formula. Log gamma plus or minus is equal to minus a under root z plus z minus √I. એની વેલ્યુ તમને ખ્યાલ છે, હમણાં જ મેં કીધી એમ. A is equal to 0.509. આ પણ વેલ્યુ ઘણી વખત અહીંયા આપેલ હોય. A is a Debye Huckel constant. Now I want to calculate the activity of. Question is calculate activity coefficient of activity coefficient of 0.05 molar KBr solution. And how it is calculated? So see, this is a KBr. It's a 0.05 molar. When you ionize it, so it gives 1 mole of K plus and 1 mole of Br minus. Both are 1 mole. So 0.05, 0.05. So first you go for calculating ionic strength is equal to 1/2 sigma Ci Zi square. 1/2 C એટલે concentration 0.05 છે અને K plus ઉપર ચાર્જ છે +1 એનો સ્ક્વેર. પછી સિગ્મા છે એટલે સમેશન. Then next again Br minus concentration is 0.05 અને એનો ચાર્જ જે છે એ -1 છે એનો સ્ક્વેર. So it become 1/2 0.05 plus 0.05. So it become divided by 1/2. So your answer become 0.05. This is the ionic strength. Now you go for calculation of activity coefficient. So log gamma plus or minus is equal to minus 0.509. પછી Z પ્લસ અને Z માઇનસ છે એટલે 1 અને -1 ચાર્જ બંનેનું મલ્ટિપ્લિકેશન -1 થશે, બટ મોડ છે એટલે +1 જ આન્સર આવશે એનો. અંડર રૂટ ionic strength 0.05. આ બધાને સોલ્વ કરી અને એનો એન્ટીલોગ જોશો તમે. અને એન્ટીલોગ જોશો એટલે 1.29 આવશે સમથિંગ. In this way you can calculate activity coefficient. Suppose if you want to calculate ionic strength for mixture, then what happens? Suppose if you having mixture of, question is calculate ionic strength of mixture 0.01 molar BaCl2 and 0.01 molar NaCl. How to calculate it? So see, this is a BaCl2. It ionized to gives Ba plus 2 plus 2Cl minus. Its concentration is 0.01. So here it is also 0.01. Here it is 2 moles. So it's a 2 into 0.01 is equal to 0.02. Now this is, now you can go for ionic strength calculation. 1/2 Ci Zi square. What is NaCl? NaCl is ionized 2 Na plus Cl minus. Both are 1 mole. So BaCl2 gives Ba plus 2. So Ba plus 2 Ci Zi square. Ci, that means 0.01. Zi square means 2 no square plus 2Cl minus છે એટલે એનું concentration થશે 0.202 into Zi square એટલે -1 no square. Then plus Na plus 0.01 into charge plus 1 no square plus 0.01 into -1 square. આ બધાનું સમેશન્સ કરી દેવાનું આ રીતે. 0.01 into 4, that means 0.04, 0.02, 0.01 and 0.01. So it become 0.08 divided by 2, that is 0.04. This is the ionic strength. So calculation of ionic strength is very, very easy. It's an easy task. If you are knowing the formula, then you can easily calculate ionic strength. This is the application of one of the very important law that is called Debye law. So is there any doubt in this topic? See here it's BaCl2 means Ba plus 2 and 2Cl minus એટલે Ba પર ચાર્જ જે છે એ ચાર્જ પ્લસ 2 છે એટલે 2 નો સ્ક્વેર કરવો પડે અને Cl ઉપર ચાર્જ -1 જ છે પછી ભલે 2 મોલ હોય બટ -1 ચાર્જ છે તો -1 નો સ્ક્વેર કરવાનો થાય. So that become +1. Suppose you are given 10 millimole, that means if you divide it by 1000, suppose your question is like calculate ionic strength for 10 mm Na2SO4. So 10 millimole means 0.0 1000 થી divide કરી દિયો. Okay, 0.01 molar solution. 1000 થી divide કરી દિયો ને. Molarity મળી જશે. Now how to calculate it ionic strength? So ionic strength is equal to 1/2 Ci Zi square. See, આનું આયોનાઇઝેશન કરશો એટલે Na2 Na+2 Na+ SO4 -2 એટલે આ 0.01 છે, so it's a 2 into 0.01, that is equal to 0.02, and this is only 0.01. So first you go for Na plus, charge. Na plus no charge 1 છે, so 1 square into Ci એનું concentration છે 0.02, so it's a 0.02. ચાર્જ મેં પહેલા લખ્યો છે પ્લસ સમેશન છે સિગ્મા CI ZI સ્ક્વેર, ZI એટલે ચાર્જ -2 છે, SO4 નો એનો સ્ક્વેર પ્લસ એનું કોન્સન્ટ્રેશન 0.01 છે, so it become 1/2 0.02 plus 4 થઈ જશે 2 નો સ્ક્વેર 0.04 is equal to 0.06/2, that is equal to 0.03. This is the ionic strength. In this way you can calculate ionic strength. The ionic strength calculation related example છે પૂછી શકે. And Debye law is very important, where value of A is 0.509 or you can say 0.51 at 298 Kelvin temperature. Value of Debye constant A is, in this equation, say value of A is 0.509 or you can say 0.51 molar raised to 1/2 at 298 Kelvin temperature. So this is about Debye or Debye limiting law. So I think this is the end of this electrochemistry chapter here. Thank you very much.